GATE 2015 Civil Engineering Set 1 Question 31. The composition of an air untrained concrete is given below. Water is 184 kg per meter cube. Ordinary Portland cement is 368 kg per meter cube. Sand is 606 kg per meter cube and coarse aggregate is given as 1155 kg per meter cube. Assuming the specific gravity of OPC, sand and coarse aggregate to be 3.14, 2.67 and 2.74 respectively, the air content needs to be found in liters per meter cube. The relevant NPTEL reference has been listed. So coming to the useful data, concrete will have a number of components. So the first component generally will be ordinary Portland cement. This would be mixed with water. Then there would be fine aggregate, coarse aggregate, and then there will be some air content also in the concrete. So these are the number of components. So each component will have some mass per cubic meter of concrete. So let us say the mass of cement is C and the density is given as rho C. So the volume of cement will be equal to the mass divided by rho C. Similarly, let us call the weight of water as W, density as rho W. So the volume of water will be W by rho W. Similarly, for fine aggregate we will have VFA equals the mass of fine aggregate divided by the density of fine aggregate, and for coarse aggregate we would have the mass of coarse aggregate divided by the density of coarse aggregate. Once we know the volumes of the individual components, we can add them together and that would form a certain volume which is called as the solid volume in the concrete or the mass of the matrix, and this can be subtracted from 1 to get the air content. This is because totally we have 1 cubic meter of concrete in which the cement, water, fine aggregate and coarse aggregate will occupy certain volume, and when we subtract that from the unit cubic meter, whatever remains will be the air content. So in this case we have been given water, that is 184 kg per meter cube. It means that in every cubic meter of concrete there is 184 kgs of water. So using this we will have the volume of water as the mass, that is 184 divided by the density of water. So the density of water would be 1000 kg per meter cube. So substituting that value we would get the volume of water as 0.184 meter cube. Next we will do this for cement. So cement is given as 368 kg per meter cube. So the volume of cement would be equal to the mass of cement in each cubic meter, that is 368 divided by the density of cement. So the specific gravity of cement is mentioned as 3.14. So the density would be specific gravity into 1000, so that would be 3140. Using this the value would become 0.117 meter cube. Next, for fine aggregate, that is sand, it is given as 606 kg per meter cube. So the volume of sand would be equal to 606 divided by its density. So the density of sand is mentioned in the form of specific gravity, that is given as 2.67. So that would become in the form of density as 2670, and this would become 0.227 meter cube. Next we have our coarse aggregate, which is given as 1155 kg per meter cube, which indicates that 1155 kg of coarse aggregate is present in each cubic meter of concrete. So using this we will have VCA equals 1155 divided by the density of coarse aggregate. So the specific gravity of coarse aggregate is mentioned as 2.74. So the density would be specific gravity into 1000. Using this we will have the value as 0.421 meter cube. When we add all the volumes, that is cement, water, sand and coarse aggregate, the value would turn out to be 0.949 meter cube, that is the volume occupied by the matrix. So using this the air content will be 1 minus Vs, which would be 1 minus 0.949, which can be approximately 0.05 meter cube. This can be multiplied by 1000 to convert it to liters, so it will be 50 liters, and this calculation has been done per cubic meter, so this would be per meter cube of concrete. So the air content is 50 liters per meter cube. The relevant NPTEL reference has been listed.